Hi, this is Jeff Coronado on behalf of JCSC, and this is Bridging the Gap. So it's an ongoing session of structural engineering design tutorials that we have here at JCSC. In essence, to bridge the gap. It's intended for young structural engineers. Maybe you're still in school and you're looking to get started on your structural engineering career, and you're trying to get a head start on the things that you're going to encounter in practice, or you've been in practice for a little while. And like all of us, there's just so many questions from where school leaves off, and in terms of how to design in real world conditions. So with that in mind, let's get started here. We have a question from a young engineer. Basically, what it comes down to is, what's the order of preference of steel bolts? So, okay, a valid question. Let's take a look at that to see, for standard steel construction, not specialty areas, just standard steel construction. What is the hierarchy of steel bolts that we use in practice? All right, so with that, let's see if we can scroll down here. And here's how I would approach this. This is an excerpt. This is table 7.1. It's table 7.1 from the AISC manual. And I'm only using this to illustrate really the bolt sizes, not so much the values. So what we're focusing on here is probably this part of it. All right, so with that in mind, then let's see if we can zoom in a little bit on that. See if we can. Yes, okay. And actually, I think we are primarily going to focus on these values here, these entries in the table. So the first thing, here's what we're going to do. Let's compare these values, these values. This one, this one, this one, this one, and this one. And the reason I'm doing that is because then I can compare capacities under similar circumstances for different bolt types. So it gives me an idea of, as much as possible, comparing apples to apples, which one has the lower capacity and which one has the higher capacity, right? So that's what I would try to do there. Let me clear this. And so with that in mind, it does look like A307 has the lowest capacity. And again, I am looking at this value, right? 7.36, you can see that there. So this has the lowest capacity. So A307 looks like it's the material of boat that has the lowest capacity. Hence, I'm going to think it's probably the most cost effective. Not always the case, but I think in general, it's fair to say that the lower capacities, the lower the capacity of the material, the more cost effective it is. So a fair place to start. A307, just so that you know, A307 steel you know what, let me do this in yellow so that we don't get confused here. A307 steel are also referred to in industry as machine bolts. Okay, so when you hear the term machine bolt, that's an A307 bolt. It's the most cost-effective bolt that we have. If you have a load that can be handled by an A307 bolt, that's your best bet. Interestingly, in this table, there's kind of a jump here. You can see that oops, I don't know that I didn't want to do that, huh? Let's do that and then see if I can get rid of that. There we go. Now notice how right here, let me change that symbol. There's kind of a slight inversion here between A325 bolts and A490 bolts. Because again, if we compare apples to apples, it looks like here we have 18.4 and it looks like here we have 23. So notice how these values do not go in order. It goes from 7 to 23 to 18, right? They don't go in order. And again, let's see if I can undo that so that we don't lose that. Again, sorry guys. Okay. Boy. Okay, I just want to erase, there we go. Okay, so what that tells us is that from A307 bolts, the next bolt in the hierarchy here is the A325 bolts. Now notice how that for the A325 bolts, and that's true also for A490, but in the A325 bolts, we do have two types of conditions here, two conditions that we can have. That's the end bolts, and we can also have the X bolts. So what we have is that we would go from A307 bolts to A325 bolts. In the A325 family, again, looking at capacities, 14, that makes sense. That makes sense. Okay, so for the A325 bolts, if we look at the N, let's see if I can change this. So if we look at this value of 14.7 and then look at this value of 18.4, the more economical would be the N. And yeah, that stands to reason. A325N bolts, the N designation means that the threads are not excluded from the shear plane. So makes sense that that would be the case. And by the way, if there's anything in this tutorial that's covered that isn't clear to you, by all means, feel free to leave us a message at the end of the tutorial and we'll try and point you in the right direction. Perhaps there's another tutorial that covers that. So we'll try to point you in the right direction. So we go from A307 to A325N to A325X. Let's see if I can erase these two. And then lastly, and I will, well, I guess I need to erase this arrow. I guess I'll erase this arrow. So let me get rid of this one. Or maybe I will try to, no. What if we try to come in from here? That way we can keep that A325X. And now let's focus on the next family of bolts. Don't want to go off into space. So let's turn this around. And that would be the A490 bolts. And you see the same conditions for the A490. You have A490Ns and A490Xs. And so that in essence becomes your third group of bolts. So in essence, if depending on your loads, your most economical bet is the A307s. If A307s don't work, then your best bet after that is A325Ns. If that doesn't work, I would probably go to A490Ns. The X is just a more difficult installation. So I would only use X's if the load were such that you would need that. Or also when the bolts need to be slip critical, then you need to go in that direction. But that's a matter for another tutorial. So so we would go A325s, and then we would go A490s. Then lastly, let's look at our bolt diameters. So those are written across here. And I'm only going to cover those four because those four are probably the most common that that we would use in practice. And you know, yes, we do have these other bolts available, going from 1 1/8 to 1 1/2. But you don't see that in practice too frequently. I would say anything beyond an inch starts to get to be kind of a push. You know, I mean, obviously, if your loads dictate that you have to go in that direction, you have to go in that direction. But I think preferably, you would stay with more bolts in this in the first group here. So let me see if I can, yeah, in this family versus the second tier. And so notice how it starts off with a 5/8 inch bolt. And yeah, I think fair to say most people would tell you that that's about the smallest steel bolt that you want to use. I know that one time, I know an old timer told me something like, take a look at the hands of the erectors, steel erectors, right? Those tend to not be real little people. So they're big people, strong people with strong big hands. You ask them to fumble around with a 1/2 inch bolt, a 3/8 inch bolt, you know, it's just going to fall through their fingers. So so I don't know, true or not, I don't know. That's the story that I got. But I think in general, most people would tell you, yeah, 5/8 of an inch steel bolt is about the smallest you would want to go with. And from there, you'd go up to 3/4, 7/8, 1 inch. Again, just depending on your loading conditions. Okay, so that's kind of the hierarchy of steel bolts. If you have, let me clear this. Let me make sure we've covered everything. Yeah, if you have, that's it. So if this was helpful to you, sure would appreciate getting a thumbs up from you. If you have any questions, comments, suggestions on what we said here, or questions, or even suggestions on what you'd like to see, by all means, leave a note at the end, leave a comment at the end. And also feel free, you can subscribe to our channel here at JCSE, and that way you can be notified of new tutorials as we post them. Okay, real good.